We've walked through the pieces: the breeder, the burner, the magnets, the mirror, the twin. Now put them together, because Kronos isn't two machines that happen to share a logo. It's one system, built in a deliberate order, where each machine makes what the next one needs. Start with the breeder. Hyperion is a spherical-tokamak, a compact cord apple shape rather than a fat donut. It runs a fusion gain of 3.424 and produces 88.7 megawatts of fusion power at a plasma current of 9.86 million amps. But here's the thing to hold on to. The breeder is not a power plant, it's a foundry. Its job isn't to send electricity to the grid, it's to make materials. It needs fusion gain, not net electrical power, and that distinction changes everything about how we judge it. What does it make? Every fusion neutron that leaves the plasma is caught in a lithium blanket. With a breeding ratio of 1.8, that blanket produces more tritium than the machine consumes, staged to grow from 1.7 toward 4 kilograms a year, plus helium-3 and a stream of 14 mega-electron-volt neutrons. Those outputs are the strategic prize. Helium-3 has been rationed since 2009, with no substitute below 300 millikelvin. Tritium is scarce and decays on a clock. The breeder makes both, and that's what links it to the burner, because the burner runs on deuterium and helium-3. The breeder breeds the helium-3. The burner burns it. One machine's product is the other's fuel. That's the fuel cycle, and it's the spine of the whole company. So the two machines aren't parallel bets. They're a chain. The breeder proves fusion gain and makes fuel and materials. The burner takes that fuel and makes clean power through direct conversion. No steam in sight. Now look at how a single machine is actually put together. The radial build. From the plasma outward, first wall, blanket, shield, vacuum vessel, and the superconducting magnets, each layer doing one job, nested inside the next like the rings of a tree. Pull that apart in an exploded view, and you see it's not exotic. It's engineering. Coils, structure, cooling loops, extraction systems, hard but assembled from parts you can name, source, and build. And every one of these machines is built twice, once in metal and once in math. A digital twin running the same physics in open simulation, validated today, ready to meet real sensor data at our first gate. The twin advises, a deterministic rules engine decides. Hard limits are never crossed. That gives us our sequence, and it's the honest one. Breed, prove, scale. First, the breeder proves fusion gain and starts making fuel and materials. Then, we prove the burner's physics, including its one gate, the thermal barrier. Then, and only then, we scale. This is the model in one line. The foundry feeds the fleet. A small number of breeders make the tritium, helium-3, and tested materials that a growing fleet of burners, Aegis at defense installations, MetroVolt behind the meter at data centers, turns into firm, clean power. It's also why we don't have to wait on any single miracle. The breeder earns its keep making scarce materials the world already needs. while the burner's physics is proven. Materials first, then power. Each step funds and de-risks the next, and all of it is engineered in the open. The physics, the simulations, the numbers you've heard. The breeder and burner designs are published with permanent DOIs, so anyone can check the work. We'd rather be verified than believed. So here's the whole machine, end to end. A foundry that makes fuel and materials, a burner that turns that fuel into clean power, a twin that runs both in the open, and one honest order to build them in. Breed, prove, scale. This is a conceptual design, validated in open simulation, not yet an operating machine. But it is one system, one logic, one chain from the first neutron to the last kilowatt.